Hey guys, in this video we're going to talk about the elements of statistical analysis that you need to know, and you can follow along with your sheet and fill things in as we go. The first thing we want to talk about is that what we're dealing with is going to be what's called univariate data. In other words, we're going to have one variable. So this might be the finishing times in a race. So if you were to track meet, like, and you recorded everybody's finishing times for doing a 100-meter dash or something. It could also be like everybody's heights, if we measured everybody's heights in the classroom, or shoe size, where it's just one thing that we're recording, one number for each person. With that, we often will talk about measures of central tendency, and this is a way to describe the data by representing the middle or center of the data, and you're probably familiar with these from a previous class. Mean is what we call the average. So you add everything up and divide by how many you have. You're used to averaging things like that. The median is the middle number. So you have to put everything in order from least to greatest and figure out what the exact middle number is. And then the mode, you will only have that if you have something occurring repeatedly, and so it would be the one that occurs the most often. And you may have to decide which of these measures best represents your data. So how are we going to choose? That's our next part. If we have no outliers, which an outlier is like an extreme value, something like if we have a really small or a really large number compared to everything else, you would use a mean if you don't have any of those, if everything's pretty close together. To do the median, it's okay to have outliers, but you can't have any big gaps in the data, okay? And then for mode, you would use that if you have a lot of repeated numbers. So let's look at these examples that I have. Which measure of central tendency should you use and why? So if you look, you have 833, 796, 781, 776, and 758. This would be a good case to use the mean because you don't have any outliers, nothing really extreme. In number 2, 27.2, 36.8, 50.4, 71.6, and then 194.7. That 194.7 is considered an outlier because if you look, everything else is smaller, it's under 100, and then this is almost at 200. So it's really far away from all the other numbers if you were to like graph them. So this will be a good case to use the median because there's one big outlier, but the rest are pretty close together. And then if you look number 3, 38, 26, 38, 20, 26, 40, 38, 46, 48. You have stuff repeated, okay? So there's a number 38 repeats itself 3 times. That's a good indicator that a mode would be what you would want to talk about. All right, looking at a kind of real-world situation, a new internet company has 3 employees who are each paid $300,000, 10 who are paid $100,000, and 60 who are paid $50,000. Which measure of central tendency best represents the data and why? Mode would be a good choice because 60 of those people out of the 73 total people that they're talking about here make $50,000. So that's a lot of repeated $50,000 values. Median would also be an okay thing to use because there are no large gaps in the middle, so that would be fine as well. All right, let's talk about some more vocabulary. Parameter. Parameter is a measure that describes a characteristic of a population. Okay, so population is key there. So that's when they say parameter, they're talking about one of those values. And so an example would be the mean income of the United States. A statistic is what they're referring to when they're talking about the characteristic of a sample. So a sample meaning a smaller group of the people that you've chosen. So the mean income of the people that live on your street would be a statistic. And compared to that, everyone you'll be talking about the mean would be called a parameter. So you do need to know whether you're dealing with a population or a sample. So remember, a population includes everyone in that particular section of thing that you're trying to find out about, and a sample is just a select few from that group. So for number 5, the IRS calculates the mean income per household. So the IRS, they're doing the mean income per household across the entire United States, so that would be a population. But if Donna asks 400 random people what their favorite season is, she's just surveying a small section of the population, which would be a sample. Now, when you take a single sample, so you don't have access to the entire population and you choose to do this sample, you are risking sampling error, okay? So one of the biggest things I want you to know about that is that the error could occur, but the more people that you use, more people you survey, the smaller the error is going to be. So the bigger the sample, the smaller the error. How do you calculate what this error might be? This is the margin of sampling error. So this will give us an interval that shows how much the responses from your sample would differ from the population. Okay, so let's say you're surveying people about their shoe size and you're taking a sample. Well, you might be in a room full of basketball players, and if you take a sample from there, they might have larger feet than the rest of the population. And so there would be some sampling error there. And how could you fix that? You could ask more people, more than just that one group, and that should bring your mean or median or mode down to something that better represents the population. But to calculate the error on this interval, how far are we away from what the real answer is, we want to use the margin of sampling error, and it's this formula right here, plus or minus 1 over the square root of n, where n is the random sample, the number of people in the random sample. Now, when you calculate this, you're going to get a decimal. You're going to move that 2 places to the right to get the percent. So looking at this example number 7, in a random survey of 2,148 people, 58% said that football is their favorite sport. Find the margin of sampling error and the interval. So we're taking a sample of the population, because obviously 2,000 people is not the whole population. And so what we would do to calculate our margin of sampling error is do plus or minus 1 over the square root of that, 2148. That would give us 0.0216. Now I want to move the decimal place 2 places to the right, so there's a 2.16% margin of sampling error. That means it could be 2.16% lower than 58 or 2.16 higher than 58. So you kind of make an interval. So if you take 58 and subtract 2.16, you get 55.84. If you take 58 and add 2.16, you get 60.16. That's the high end. So between those two numbers, the real actual answer of the population most likely lies somewhere between 55.84 and 60.16. Okay, so that would be how you calculate the interval. All right, so another example here, we have a survey of 5,669 random people, and 31% say they go to the movies at least once a month. So again, to get that sampling error, I'm going to go plus or minus 1 over that amount that I surveyed, so 5,669, or the square root of that. I'm going to get a decimal, 0.133. I'm going to move that to get 1.33%. So it's either 1.33% higher than 31 or lower than 31. So I'm going to subtract and I'm going to add to get the low and high ends of that interval. And again, what you have found is the interval where the actual population's answer would lie. So it's somewhere in that range. Okay. Measures of variation. So this is to talk about the dispersion or the spread of a data set. So you can either use variance or standard deviation, and we're going to focus on standard deviation. So standard deviation tells how closely our data clusters around the mean. So how close is everything kind of grouped toward that mean number. We are going to use our calculator, and when you're reading it in your TI-84, the mean is the x bar, the x with the line over it, so you read it x bar. The sample standard deviation is going to be a capital S, and the population standard deviation is going to be this little Greek letter. And this letter is called sigma. It's a lowercase sigma. Okay, so about standard deviation. The bigger that is, that means the more that your data goes away from the mean. It's spread out. Okay, so you have a big range of data points. If it's a smaller standard deviation, that means that the answers or the numbers were really grouped close together. Let's think about it as far as something you would know. Maybe your class took a test and the mean was an 80, so the average for the class was an 80. If you had a really big standard deviation, you could probably have a bunch of different, scores kind of all over the place. It just happened that 80 was the average of those, the mean of those. So you might have had somebody in the 20s and somebody in the 70s and somebody that made 100 and things like that. If the standard deviation is small, that means a lot of people were right around 80. So you would expect some scores in the 70s, 80s, 90s maybe, but they were closer together toward that 80. They didn't range very far. All right, so we're going to find the mean and standard deviation by your calculator, and I'm going to explain how to do that with the 84, the TI-84, but I'm also going to show you how to do it in Desmos. Okay, so when you have a problem, you want to look at it and first decide whether you're looking at a population or a sample. And so usually you're going to look at the title of the data. And if it looks like they're using a whole group, that their goal is to find the whole group thing, you're doing the population. And if it's a random sample, it may say selected or something like that. But look at the title and make a decision based on that. When you put it in your TI, you're going to hit Stat, and you're going to go to the Edit menu, and you're going to type your list of numbers in. So you just have that one list of numbers in there. And then you're going to choose Stat Calculate. So the Calculate menu, you will find what says One Variable Statistics. And when you choose that, it gives you a lot of information. If you said that your population was a sample, then you're going to be using the capital S, X. If it was a population, you're going to be using the sigma X. Okay, so if I'm looking at example 9, it's the mean and the standard deviation for this. This is the shoe sizes for an entire class. The fact that they use the word entire means that I'm probably looking at a population. So that's my note right there. But if you put that into your calculator, and I'm going to show you in Desmos in just a minute so that I can actually show you what's going on. But in the calculator, you put this in list 1, under your Stat Edit, list 1, type that in, and then do Stat Calc and choose One Variable Statistics. You should come up with an X bar mean of 8.625. And then because we said it's a population, we're going to use the sigma, and that should be 1.93. Now I'm going to show you how to do it in Desmos. Okay, so in Desmos, we're going to come over on the side and put our list in, just list it out, and I'm going to call it something, so I'm just going to call it L. So I'm going to say L equals, and that's going to be my list. I can go to my keyboard. Let me pop that up for a second. And under the Functions tab, there's a Stats column, and it has lots of different things where you can come up with the mean, the median, the min, the max. So if I wanted to know the mean, I would just type or select mean, and then I can put L since I named it L, and you'll notice it is at 8.625. I love it though because it will also come up with the median, the minimum, the maximum if I wanted it to. So like, let's say I wanted the median, even though that wasn't asked, it would be 8.5. I can check that stuff in there. What the other thing was that I wanted to know was the standard deviation. And so in that same list, you have ST deviation and STDP. The one without the P is if it was a sample, and the one with the P is for the population. So you'll notice you get that 1.92705, which is basically the 1.93 that we were talking about before. And that's because we decided it was a population. Had I known, or had I thought that my data was for a sample, I would have chosen just the regular one without the p, and I would have gotten this as my standard deviation. So you can do these things in Desmos and in the testing version of Desmos. That is, they're still available. But that pretty much concludes what you need to know for statistical analysis for this course.